Okay, so Assalamualaikum warahmatullahi wabarakatuh. Good evening, everyone. Hari ini saja tak nak buka kamera. Okay ke? Good evening. Okay, so jom kita start terus lah. Dah 92 minit kan. So kita start siap-siap. So nanti siapa yang join lambat sikit, kalau nak ke belakang pun ikut suka dia orang lah nanti. Oh, bunyi guru. Okay, so now limit and continuity. Okay, so we are at lecture 2 or out of 4, 8.1 limits. So today we are going to finish 8.1 and then we will start with 8.2 and later on 8.3. Okay, so the learning outcome for today is that at the end of the lesson, you should be able to determine the existence of the limit of the function and then find the infinite limit. So the limit for x approaching a for fx, either we get a positive infinity or a negative infinity. So that I'm going to teach you how can we get positive or negative, and then find the limit at infinity. So basically for x approaching positive infinity and limit for x approaching negative infinity. So firstly, infinite limit. So we are going to get infinity on the right hand side. This one as x approaches infinity. So we are supposed to get some value on the right hand side. Another one is that you should be able to find the limit for x approaching infinity for fx over gx when the limit for x approaches infinity for fx and the limit for x approaching infinity for gx are undefined. So what do we mean is that once you substitute the limit as x approaches infinity, you are going to get infinity over infinity. So nanti kita dapat infinity over infinity. So kita boleh tahulah hasil dia apa. Sekejap Kenapa tiba-tiba ada message? Dah start. Ada orang tak perasan kot. Okay, tak apa. Okay, so now the fifth one, use the limit for x approaches positive infinity for 1 over x to the power of n, and then the limit for x approaches negative infinity for 1 over x to the power of n. So both of them are actually 0 for n greater than 0. Okay, so now limit. Determine the existence of a limit. Right, so limit for x approaches a for fx exists if and only if the limit for x approaches a from the left hand side for fx and the limit for x approaches a from the right hand side for fx both exist and are equal. So that means we are supposed to get some value when we are looking for the limit as x approaches a from the left hand side for fx. So let's say this one you get L, and then the limit for x approaches a from the right hand side for fx. Let's say this is also L. So since L is equal to L, we're going to say that they are equal. Therefore, the limit for x approaches a for fx exists. If let's say one of them is L, another one is M, then that means the limit for x approaches a does not exist. So value 2 ni kena sama lah, baru kita boleh kata limit for x approaches a exists. Okay, next, given the function fx equal to 2x for x less than or equal to 4, 2x plus 3 for x greater than 4, determine the limit for x approaches 4 for fx if it exists. Right, so basically, if we have a piecewise function, we got to determine what is the limit as x approaches 4 from the left hand side and as x approaches 4 from the right hand side. So satu dari kiri, satu dari kanan lah. So kita kena kira dulu. So normally what did I do is that I'm gonna sketch or I'm gonna draw a number line for them first. Okay, so I got two function over here. So 2x for x less than or equal to 4. As you can see, this is for x equal to 4. So starting from 4 and below, the function is 2x. X more than 4. So starting from 4 going into the right hand side, the function is 2x plus 3. So now we're going to check the limit as x approaches 4 from the right hand side and then the limit as x approaches 4 from the left hand side. Right, so 4 from the right hand side. So if you refer to here, this is x equal to 4. So on the right hand side of 4, so the function is fx equal to 2x plus 3. So that is why over here, we are using 2x plus 3. The limit as x approaches 4 from the left hand side. So this is 4 from the left hand side. The function on the left hand side of 4 is 2x. So that is why over here, we are using 2x. Okay, and then the limit, we simply substitute x with 4. So what do we have? Is 2 times 4 plus with 3. So 8 plus 3. So this is 11. And then another one, we got 2 times with 4. So this is simply equal to 8. Okay, so now we can easily look at the value for x approaching 4 from the right hand side and the value for x approaching 4 from the left hand side. They are not equal, therefore we can say that the limit for x approaches 4 for fx does not exist. So it does not exist because the limit for x approaches 4 from the right hand side is not equal as the limit for x approaches 4 from the left hand side. So kiri dengan kanan limit dia tak sama. Therefore the limit for x approaches 4 for fx does not exist. So sometimes we call them as D and E does not exist. Okay, so let us go to the second example and let's see whether can you guess them or not. Okay, so example 2, we got fx equal to 2 for x not equal to 1 and 5 when x equal to 1. And then we have to determine the limit for x approaching 1 for fx. Right, so basically, if we have a piecewise function, we got to draw the number line a little bit so that we are very clear which function on the left hand side and which function on the right hand side. Okay, so we got x equal to 1. So as long as x is not equal to 1, we are going to have a function where we have fx equal to 2. So that means on the left hand side of 1 and on the right hand side of 1, both of them are actually fx equal to 2. Okay, so what is x equal to 5? So that is simply the value when x equal to 1. So over here, this is 5. Okay, so when we are talking about the limit, we want to calculate or we want to know what is the value as x approaches 1 from either left hand side or right hand side. So let us calculate that value. Okay, so the limit as x approaches 1 from the right hand side. So this is 1 on the right hand side. The function is 2. So this is the limit for x approaches 1 from the right hand side. The function is 2. Since this is simply a constant, it will become the constant itself. So the limit for x approaches 1 from the right hand side of 2 is simply 2. And then the limit as x approaches 1 from the left hand side. So this is 1 on the left hand side. The function is 2 again. So this is actually the limit as x approaches 1 from the left hand side of 2, which is simply equal to 2. And then as you can see on the right hand side and on the left hand side of 1, we simply get the same value. Therefore, we can say that the limit of x approaches 1 for fx must be equal to 2. And it does exist. So if let's say the question asks, does the limit exist? The answer is yes. The limit exists and the value is equal to 2. So since the limit for x approaches 1 on the right hand side of fx is equal to the limit for x approaches 1 from the left hand side for fx, then the limit as x approaches 1 for fx is equal to 2. So the limit does exist because we are having some similar number, or we are having the same number on the left hand side and right hand side. Okay, so done with this. Next. Right, so example 3, given that the function f(x) is equal to the modulus of x minus 2, find the limit as x approaches 2 for f(x). Right, so basically, if you have modulus, that means you need to open the modulus sign. To open the modulus sign, firstly, we are going to have x minus 2 for x greater than or equal to 2. Another one is the negative of x minus 2 for x less than 2. So in case you are wondering why we are having two different functions, the graph for an absolute value looks like a V. So we are going to have a positive gradient on the right hand side, which is this function. And then on the left hand side, we are having some negative gradient. So this function over here. Okay, so now we want to find out the limit as x approaches 2 for f(x). So that means you should calculate 2 on the left hand side and 2 on the right hand side. So let us see what is the value as x approaches 2. Okay, so now let us draw the number line first, x equal to 2. So on the left hand side, the function is negative x minus 2. On the right hand side, the function is x minus 2. So normally for me, whenever I start with limit, I need to draw them first before I can easily see is it going to the left or is it going to the right. Okay, next. Right, so now the limit as x approaches 2 from the right hand side. So this is 2 on the right hand side. The function is x minus 2. So this is the limit as x approaches 2 from the right hand side. The function is x minus 2. And if you substitute x with 2, you are going to get 2 minus 2, which is simply equal to 0. So this is approaching 2 on the right hand side. Now, the limit as x approaches 2 on the left hand side. So we are approaching 2 on the left hand side. The function is negative x minus 2. So this is the limit as x approaching 2 on the left hand side for the negative x minus 2. Substitute x with 2 again. So we got 2 minus 2 multiply with negative 1. So it will become 0. And then what is the value for them? So basically, on the right hand side, the value is 0. On the left hand side, that is also 0. So that means we do have an equal number on the left hand side and right hand side. So the limit for x approaches 2 on the right hand side is equal to the limit as x approaches 2 on the left hand side. Therefore, we can say that the limit for x approaches 2 for f(x) exists, and the value is definitely equal to 0. Because for both of them, we are going to get a 0. So far, so good, everyone. Are you guys doing fine? Hopefully, you guys are doing fine. Right, good then. So let me continue. Okay, so example 4, a function f is given as f(x) equal to the modulus of x plus 1. So this is basically for x less than 0, 2 for x equal to 0, e to the power of negative 2x for x greater than 0. Okay, so now find out the limit for x approaching 0 on the left hand side for f(x), the limit for x approaching 0 on the right hand side for f(x), and then the limit as x approaching 0 for f(x). Okay, so I'll give you a few minutes for you to answer them, perhaps around 2 minutes. So try to calculate what is the limit as x approaching 0 on the left hand side, approaching 0 on the right hand side, and make a conclusion. tengah menghadam. Dia kena kira sikit-sikit. You must calculate on the left hand side, you must calculate on the right hand side, and then see, do you get an equal number or not? Normally we need to use this one if we have something with an absolute value or something with a piecewise function. So selalunya dalam dua keadaan lah, piecewise ataupun absolute value. So normally you have to calculate on the left hand side and right hand side first before you can see do you have the limit or not. Okay, time's up. I nak tengok dapat ke tak. Okay, so do check you're working together with me. Okay, so firstly, what do? We draw a number line a little bit, just a briefly sketching to see which one on the left hand side and which one on the right hand side. Okay, so I got x equal to 0 over here. And then on the left hand side, on the right hand side, I got e to the power of negative 2x actually. And then the modulus of x plus 1. This is suppose e negative 2x. Okay, so now on the left hand side, we got x plus 1, the modulus of x plus 1. On the right hand side, I have e to the power of negative 2x. Okay, so now let us calculate the limit as x approaches 0 on the left hand side for fx. So this is basically 0 on the left hand side. The function is modulus x plus 1. So let us substitute x with 0 over there. So we got the modulus of 0 plus 1, which is actually equal to 1. And then the limit as x approaches 0 on the right hand side for fx. So this is actually e to the power of negative 2 times with 0. So e to the power of 0, which is equal to 1. Therefore, the limit for x approaching 0 on the left hand side for fx is actually equal to the limit as x approaches 0 on the right hand side for fx. And we will say that the limit for x approaching 0 for fx is actually equal to 1. So this is 1, this is 1. Therefore, the limit for x approaches 0 is equal to 1. So calculate the left hand side first, calculate the right hand side first, left, right. And if they are both equal, then we can say that the limit for x approaching a number without left hand side or right hand side will be 1. Okay, next. Right, so this is infinite limit, infinite, whatever. Okay, so if the value for fx increase without bound as x approaches a from the right hand side, we're gonna write them down as limit for x approaches a from the right hand side, fx equal to positive infinity. The other one, we're gonna write them down as negative infinity. So basically, you should try to substitute those values first before we can easily determine whether they are positive or negative infinity. Right, so I'll teach you later on how do we know positive or negative. Okay, never mind, next. Right, so given that fx is equal to 1 over x minus 1, find the limit as x approaches 1 on the right hand side for fx and the limit for x approaches 1 on the left hand side for fx. So we got a function. So fx equal to 1 over x minus 1. So that means if this is 1, on the left hand side, the function is 1 over x minus 1. On the right hand side, that is also 1 over x minus 1. So we got similar function on the left hand side and right hand side. Okay, so the limit as x approaches 1 on the right hand side for fx. So approaches 1 on the right hand side, the function is 1 over x minus 1. So replace the place for fx with 1 over x minus 1. So it will become the limit for x approaches 1 on the right hand side, 1 over x minus 1. And if you substitute with x equal to 1, you are going to get 1 minus 1, which is exactly equal to 0. So we are going to get 1 over 0, which is infinity. Okay, so how do we decide whether do we have positive or negative infinity? Okay, so do check you are approaching 1 on the right hand side. Okay, so if this is 1, on the right hand side of 1, choose some number on the right hand side of 1. Normally for me, I prefer to add 0.1, so I'll choose 1.1. Okay, so 1.1, you minus them with 1, we are going to get some positive number, right? So that is why you are having 0 with a plus. What does it mean is that as we are approaching 1 on the right hand side, when we minus that number with 1, we're simply going to get some positive number, but it will be closer to 0. So positive, but closer to 0. So that is why this is 0 with a plus. So this is 1. 1 divided with some positive number. So that is why the symbol over here will be positive infinity. So let us try that with another question. Okay, so this is the limit for x approaching 1 on the left hand side for fx. So 1 on the left hand side is 1 over x minus 1 again. So substitute with 1 over x minus 1 again. Okay, so again you have 1 over x minus 1. You substitute with 1 over here. So 1 minus 1 is simply equal to 0. So 1 over 0, it will become infinity. So how do we decide? It will be a plus or minus. So if we have 1 over here on the left hand side, so if this is adding 0.1 on the left hand side, normally I will deduct 0.1. So this is 0.9. So 0.9, you minus them with 1, we are going to get some negative number, but it will be quite close to 0. So that is why this is 0 with a minus. So that means we do have some positive number over there. So 1 is a positive number divided with some negative number. So that is how I know this is definitely a negative number. Okay, so let me repeat that again. So this is the limit for x approaching 1 on the right hand side for fx. So basically the function, so this is 1. On the right hand side of 1, the function is 1 over x minus 1. So we will replace them with 1 over x minus 1. So substitute the value of x with 1. We are going to get 1 over 0, which will give us infinity. So to decide whether to have positive or negative infinity, we need to substitute a certain value first. So since we are approaching 1 on the right hand side, normally for me, I'll adding 0.1 to that number. So this is 1, I add 0.1, I'm going to get 1.1. So 1.1 minus with 1, that is actually some positive number. So this is 0 with a plus. So 1 is a positive number dividing with some positive number. That is how we know this is definitely a positive infinity. Limit for x approaching 1 on the left hand side. So based on our number line, on the left hand side, the function is 1 over x minus 1. So that is why I replace fx with 1 over x minus 1. So substitute x with 1, 1 over 1 minus 1, so 1 over 0. This is definitely infinity. So to decide whether is it positive or negative infinity, I substitute a certain value first, other than 1 of course. So I'm approaching 1 on the left hand side. So normally I'll deduct 0.1 to that number. So this is 0.9. So substitute x with 0.9. I will have 0.9 minus with 1. So I do know this is some negative number. So 1 is a positive number. divide with some negative number. So that is how I know this is negative infinity. Okay, so done with that. Next. Okay, so find the limit as x approaches 2 on the left hand side for fx and the limit for x approaches 2 on the right hand side for fx for each of the following function. Right, so basically I'll give you around 3 minutes, I think. Will 3 minutes do? 5 lah, 5 minutes. So until 9:33. So I'll give you guys 5 minutes for you to try them first. Basically, this is infinite limit. So sepatutnya mesti dapat infinity lah. I'll give you one hint. You definitely going to get infinity. So your job is to check is it positive or negative infinity first. Okay, so 5 minutes. Do check them. Okay, so now let us check your working then. Okay, so firstly A, so the limit for x approaches 2 on the left hand side for fx. So this is the limit for x approaches 2 on the left hand side for 1 plus x over x minus 2. So basically substitute x with 2, we are going to get 3 over 0. So this is definitely equal to infinity. Right, so basically to decide, is it a plus or is it a minus? So if we have 2 on the left hand side of 2, this is 1.9. So we minus with 0.1, 1.9. So 1.9 minus 2, so this is some negative number. So 3 over negative number, so this is definitely negative infinity. Okay, so x approaches 2 on the right hand side for fx. The limit for x approaches 2 on the right hand side, 1 plus x over x minus 2. Again, if you substitute with x equal to 2, you are going to get 3 over 0, so it will become infinity. Again, to decide whether is it a plus or is it a minus, so if we have number line, so this is 2 on the right hand side, perhaps around 2.1. So we got 2.1 minus 2. So this is 0.1, a positive number. So this is 0 with a plus. So a positive number divided with some positive number. So that is how at the end we are going to get a positive infinity. So on the left hand side, negative infinity. On the right hand side, positive infinity. Okay, next. So the limit for x approaches 2 for fx. For 1 plus x squared over x minus 2 over x plus 1. Okay, so substitute x with 2 first. So you're basically going to get 1 plus 2 square. So this is 5 over 0 times with 2 plus 1, so 3 then. So we got 5 over 0, so this is definitely infinity. So to decide, is it a plus or is it a minus? Normally, what I normally do is that this is some number, so 5. So this is 0, and then we got 3 over here. So you need to know what is this number. So this is 2 on the left hand side, this is 1.9. So 1.9 minus with 2, this is 0 with negative. So we got a positive number over some negative number and then some positive number. So positive, negative, positive. This is definitely negative infinity. The other one, so 1 plus x squared over x minus 2, x plus 1, substitute x with 2. And then 5 over 0, this is definitely infinity. Okay, so we got 2 on the right hand side of 2, this is 2.1. So you substitute, what do you have here is 5 over 0 multiply with 3. So if I substitute with 2.1, 2.1 minus 2, this is 0 with a plus. So that is how I know positive over positive, positive. So positive, positive, positive. This is definitely positive infinity. Okay, so 2 on the left hand side, negative infinity. 2 on the right hand side, this is positive infinity. Okay, so hopefully you guys are doing well. So let us continue then. So this is the limit at infinity. Right, so basically we want to calculate the limit for x approaches positive infinity for fx. Okay, so what do we need to know is that the limit for x approaches positive infinity for 1 over x to the power of n, this is actually equal to 0. And another one is that the limit for x approaches negative infinity for 1 over x to the power of n, this is also equal to 0. Okay, so that means if let's say x approaches positive infinity, you substitute x with infinity, it will be something like 1 over infinity. So this is definitely equal to 0. So that is what we mean over here. The same thing over here, if you substitute x with negative infinity, so 1 over negative infinity, this is also equal to 0. So 1 over a very big number, 0. 1 over a very big number, 0. Okay, so now find the limit at infinity for the following. Okay, so I'll say, let me do 2 of them first and then I'll let you to try C. Okay, so let me try to do A. So this is the limit for x approaches infinity for x squared plus 3. Okay, so as x approaches positive infinity, so x is actually infinity. So we got infinity with a square plus with 3. So infinity square is simply infinity. You add 3 to that big number. So that is definitely positive infinity. Therefore, the limit for x approaches positive infinity of x squared plus 3. This is also positive infinity. Okay, so the next one. As x approaches negative infinity, what is 5 over infinity? So 5 over infinity is actually approaching 0. So 5 over infinity is approaching 0. So what does it mean? Is that if we have a limit for x approaches negative infinity for 1 over 5 over x, 1 minus 5 over x. So this one will be approaching 0. So that means we are going to get 1 minus 0. So this is simply equal to 1. So this is not a plus, it's supposed to be a minus. Tapi tak apalah. Okay. Can you guess for C? What do we have for C? For C, we have something with a square, right? Okay, so as x approaches positive infinity, x minus 3 with a cube. So if you substitute x with infinity over here, we got infinity to the power of 3. So this is also positive infinity. And then what do you do next? Is that you're going to take the limit for x approaches positive infinity of 2 over x minus 3 to the power of 3. And this one over here, we already say that this is actually positive infinity. So 2 over infinity, this is actually equal to 0. Just in case you didn't notice, infinity square, this is actually infinity. If you have, let's say, infinity plus 1, this is also infinity actually. If you have infinity minus 1, this is also infinity actually, because infinity is a very big number. And if you have 1 over infinity, this is approaching 0. Okay, so limit at infinity for a rational function. Okay, so just now we are having something like infinity square, 1 over infinity, and so on. But I didn't say anything if we have infinity over infinity. So what will happen if we have infinity over infinity? If, let's say, when you want to calculate the limit for x approaching infinity for a rational function, fx over gx, and when you substitute, you're going to get infinity over infinity. What do you need to do is that you need to divide each term by x to the highest power of the denominator. So what do you need to do? Refer to your gx, refer to your denominator, and check what is the highest power of your denominator. Is it x, or is it x squared? Is it x cubed? And so on. So you need to check what is the highest power of your denominator. And let's say the highest power is x squared. What we are going to do is that we're going to divide our numerator together with our denominator with x squared. Okay, so for example, let us try to do A first. So this is the limit for x approaches positive infinity for 2x cubed plus x squared minus 3 over x cubed plus x plus 2. Okay, so what do you do first? Substitute with infinity. So this is 2 infinity plus infinity minus with 3. So this is definitely infinity. Substitute with infinity over here, infinity cube, infinity plus infinity, infinity, infinity plus 2, that is also infinity. So we are going to get infinity over infinity. If we have infinity over infinity, we need to check what is the highest power of our denominator. So referring to your denominator, the highest power is actually x cubed. Therefore, we're going to divide each term in our numerator with x cubed and each term in our denominator with x cubed as well. So atas bawah dua-dua bahagi dengan x cubed. Okay, so divide them. Alright, so divide by x to the highest power. So we are going to divide with x cubed, x cubed, x cubed, everything with x cubed. And then what do you do next? Simplify them first. So simplify them before you take its limit. So 2x cubed over x cubed cancel out. So we are going to get 2 x squared over x cubed. So this cancel. We are going to get x. This is simply 3 over x cubed over x cubed. So this is 1. X over x cubed. So this is x squared. And then 2 over x cubed. So simplify that one first. So we got 2 plus 1 over x minus 3 over x cubed over 1 plus 1 over x squared plus 2 over x cubed. So what do you do next? You have to substitute x approaches infinity. Right, so do you remember before this, what do we have is that the limit for x approaches positive infinity for 1 over x to the power of n. This is actually equal to 0. And the limit for x approaches negative infinity for 1 over xn, this is also equal to 0. So we are going to use this over here. So this is the limit for x approaches positive infinity. So since we have 1 over x, a fraction over here, if you are using this definition, you will see that this limit is actually equal to 0. 3 over x cubed, this is also some number over x to the power of n. So this is also 0. 1 over x squared, this is 1 over x to the power of n. So that is also 0. 2 over x to the power of 3. So that is also 1 over x to the power of n. So that will also give us 0. Right, so now substitute the value. So we are going to get 2 plus 0 minus 0 over 1 plus 0 plus 0. And then it will become 2 over 1, which is simply equal to 2. Okay, so this is A. So now let us try B first. So this is the limit as x approaches negative infinity for x over 3x squared minus 1. So perhaps I'll give you 1 minute for you to try them. What happened if you substitute infinity with infinity? What happened? Do we have infinity over infinity? If we have infinity over infinity, what do we need to do? And etc. So 1 minute. Right, so once you have the answer, can you write down the answer so that we can check? Do you get them right or not? Okay, so saya tunggulah untuk awak tulis jawapan. Awak dapat jawapan berapa? Oh, Puang dapat kosong. What about others? By the way, saja nak main dengan banner. I'll remove them later on. Other than Puang, what do you guys get? So Pong and Ikuan, both of them got a 0. What about everyone else? Okay, so let us check then. But I'm quite sure the answer is right. Okay, now if you try to substitute the limit first, so substitute the limit for x approaches negative infinity for x, you are going to get negative infinity. Substitute the limit for x approaches negative infinity for 3x squared minus 1. You are going to get infinity, so we are having something with infinity over infinity. Tak kisahlah plus minus infinity tu. So we are having infinity over infinity. So we got to divide with the highest power of denominator then. So the highest power of the denominator is x squared. So we divide everything with x squared. So you are going to get the limit for x approaches negative infinity for x over x squared. Just in case you couldn't see the square. Square, square, square. Okay, so x over x squared, 3x squared minus 1 over x squared. We're gonna simplify them first. So this is 1 over x, 3x squared over x squared minus 1 over x squared. And then simplify, 3x squared cancel out. So this is simply 3. Substitute with infinity. So we are going to use the limit for x approaches negative infinity for 1 over x to the power of n. This is actually equal to 0. So we are going to use this. So that means 1 over x is 0. 1 over x squared, this is also 0. So we are having something like 0 over 3 minus 0. So this is 0 over 3, which is simply equal to 0. So tahniah, dapat dah, betul. Okay, so now the next one. So we got a limit for x approaches negative infinity for x plus 1 over the square root of x squared plus 1. Right, so again, we do try to substitute x with infinity. So what we are going to get is that the limit for x approaches negative infinity of x plus 1. This is negative infinity. And if you substitute with negative infinity over here, you got a square. So instead of negative infinity, it will become positive infinity with a square root. So it will become positive infinity again. So if you try to substitute, you are going to get negative infinity over infinity. So that means we should divide with the highest power of our denominator. Okay, so check your denominator and check what is the highest power of denominator. Right, so basically I got x squared in my denominator. So this is x squared. However, outside of this, I got a square root. So that means I'm not having x squared as the highest power because I got another square root outside. So this is x squared to the power of half, which means this is simply x. So the highest power of the denominator is x. So dia bukan x square lah because we must apply the square root first. Okay, so divide everything by x. So we got x plus 1 over x and then the square root of x squared plus 1 over x. However, over here we can easily divide them. These two, this is quite hard. We cannot easily divide them. Therefore, we need to change our denominator over here. Sebab bila atas ada cert, bawah tak ada cert, kita tak boleh nak simplify. Therefore, I have to change this x over here into something with a cert. Therefore, I change it into the negative of square root of x squared. Right, so x is a positive number and x can be a negative number. So when it comes to the square root of x squared, it can mean two things. So you can either have a positive of square root of x squared or you can have a negative square root of x squared. So this is for x greater than or equal to 0 and this is for x less than 0. So when you want to substitute x with negative infinity, it simply means that x will be a negative number. Therefore, when we want to change the x into a set, we need to use a negative square root of x square. So dia tak boleh pakai square root of x square biasa sebab nilai x yang kita nak ganti adalah nilai yang negatif. Okay, so therefore I got to change it into negative square root of x squared. So now this is a set over a set. I can actually simplify them into one set. So I can actually combine them into a set a over b. So what do we have is x over x. So 1 over x, 1 over x, and then x squared plus 1 over x squared. So simplify your denominator over here. So it will become 1 plus 1 over x squared. And then of course we're going to use the limit as x approaches negative infinity for 1 over x to the power of n. This is actually equal to 0. So this one over here, this is 0. This one over here, that is also 0. So what do we have is 1 plus 0 over the negative of square root 1 plus 0. So this is actually equal to negative 1. Okay, so now the last question for today. Limit as x approaches positive infinity of the square root of x squared plus 4 over x plus 3. Again, substitute x with infinity. So you are going to get infinity over infinity. So substitute x with infinity, we are going to get infinity over infinity. So what do we do if we have infinity over infinity? You only have one way, which is to divide with the highest power of denominator. So check your denominator, what is the highest power of x? So basically the highest power of x is simply x. So we are going to divide everything by x. Okay, so basically in our numerator, we are going to get x squared plus 4 over x. In our denominator, x plus 3 over x. Okay, so this one over here, we got a set up here, and then this one, this is not a set. Therefore, I need to use the definition of a square root to change this one. So what is x? X can mean two things. So I can either have a square root of x squared or the negative square root of x squared. So that totally depends on the value of x that I want to substitute. So this is for x greater than or equal to 0. This is for x less than 0. So since I'm looking for x approaches positive infinity, so this is definitely for x greater than 0. So I'll use positive of square root of x squared. So we are going to change this x to become square root of x squared. So it will become square root of x squared plus 4 over square root of x squared over x plus 3 over x. And then of course you have a set, so you can actually combine them into one big set. So it will be a set x squared plus 4 over x squared. So this one separate them into two. We got x squared over x squared, which is 1, and then 4 over x squared over 1 plus 3 over x. And then, of course, we are using the limit for x approaches positive infinity of 1 over x to the power of n. So this is simply equal to 0. So that will mean 4 over x squared is equal to 0. 3 over x, this is also equal to 0. So we are going to get set of 1 over 1. So this is definitely equal to 0. Okay, so my advice is that if you do have the limit for x approaches infinity, so you need to handle the limit for x approaches negative infinity or the limit for x approaches positive infinity, and somehow inside here it involves a square root. What you need to do is that you need to check first the definition, just like what I did previously, something like this. So do make sure you know, do you want to substitute with a positive number or a negative number? So kena be careful lah. So kalau kata kita ada limit x approaches negative infinity, kita ganti dapat infinity over infinity, infinity over infinity, dan dekat function ni ada something dengan square root. Bermaksud kita kena fikir sikit lah masa kita ganti tu positif ke negatif. Macam tu lah. Okay, so now I think that's it for today. I'll see you guys tomorrow for lecture 3. So tomorrow we're gonna learn about asymptote, the vertical and the horizontal asymptote as well. Right, so I'll see you guys tomorrow. Thank you everyone. Have a nice day. Day ke dah habis kot. Good night then. Bye.